Hi, my name is Glenn Allen with Asylum 7 Studios, and I am the lead software developer and lead architect here at Asylum 7. And I've been working on the Cgda framework for the past several months, and I'm finally getting things into the point that I'm willing to show it off just a little bit here. And it's a native game development API. It actually stands for Computer Game Development Architecture. And it's written in C++11, and it's intended to be a replacement for XNA, but calling it an XNA clone would not be doing it justice. So what I'm going to do is I'm going to walk you through a sample application here. And what I've done, I've gone ahead and created this model of a Rubik's Cube in 3D Studio Max. And I've already triangulated it and exported it as an OBJ, and I've got it here. You can see it in Visual Studio with the material library. And, of course, the textures. And I've exported the shaders as well. These are GLSL shaders, and that's kind of beyond the scope of what I'm going to be looking at today. But I just wanted to show you that they are, in fact, there, and they are, in fact, GLSL as opposed to HLSL. So what I'm going to be doing is creating a class, and I'm going to call it example02 to match the project here. And it is going to be a subclass, or child class, of a Cgda game. So I'm going to go ahead and let the IDE help me implement these virtual methods. I want to override load content, update, and render. And go ahead and mark those as protected. So here, when we create the object, I'm actually going to create it as a C++11 smart pointer. And I'm going to call it P, a unique pointer to example02. And I could just as easily, in fact I will, it's a pointer to a game. And we call run. And that's it. That will initialize, comment those out, initialize the application and get us a basic window here, and it does. So the first thing we're going to do is go ahead and set the graphics device to clear the screen to good old cornflower blue. And display that. And it works. Great. So now we're going to need a few objects. We're going to need a model to hold our Rubik's Cube. We're going to need a matrix to represent the world matrix, or the model matrix. We can call it world here. We're going to need a matrix for the view and the perspective calculation. And I'm going to go ahead and initialize these with the constructor with an initializer list. Initialize the world to the identity matrix. Initialize the view. Create a look at matrix, and I'm going to position the camera at 0, 0, 10. That sounds good. Should line up right. We're going to look at vector 3, 0, and our up vector. Now we need to initialize the projection. A field of view vector matrix. Now we're going to set this to a 45-degree FOV, and some of you are not going to like that, but um, that's just how we're doing it for the sake of this tutorial. And again, you'll notice that these functions look very, very similar to their Cgda counterparts. That is intentional, but you're going to see some deviation from that in just a moment. There we go. So we've got a 45-degree projection, or field of view, 45-degree field of view, 16:9 aspect ratio, near plane at 0.1, far plane at 100. Oh, what's going on here? Oh. There we go. That should be better. The next thing we need to do is load the model. We'll call content.load. We're loading a model. And the path is going to be rubics.obj. Let's set the root directory for the content manager first. Just for completeness sake. And we're also going to need to load in the shader program. The effects framework is not quite complete, so this is where you're going to see some derivation from Cgda. So we're going to say for, and I'm going to use the C++11 range for here. I'm going to say mesh model, Rubik's meshes. And for auto part in mesh parts part program equals content.load, and we are loading a shader program. Now this is functionality that should be automated in the future, but for now it's a necessary evil. It is the basic dot effect, which I will look at briefly for you here. And it lays out the name or the type of shader and then a path relative to the root directory of the actual GLSL file. It's a simple file format. It's going to be replaced in the future, but again, for now, it's all we have. Alright. Next, we want to actually render this thing to the screen. So we're going to loop through the mesh again, but this time we're going to bind the program, and we're going to set the uniforms. Oh. Nope. And I believe this is called model in the actual Vertex shader. It is. Well, let's just update this. Widget world. Yeah, that'll be just a bit more consistent. Now we'll set the view. And the projection. Next thing we need to do is actually draw the mesh. And that should, if everything goes right, yeah, it does. It displays our Rubik's Cube. It doesn't look very interesting. There's no animation or anything, so let's go ahead and take care of that. We've got the world matrix here, so why don't we create a transformation on that? let's create from an axis angle. 1, 1, that sounds good. And let's do a full or a half rotation every second. That should be pretty fast. Let's just see if that works. Get build errors. Ah, okay. So I've left this function out for now, but that's alright. We'll do... Yeah, let's just do it this way. Create a quaternion with a rotation, and let's go ahead and initialize that. Identity. Okay, so our rotation will be, let's see. I may have to check that in the API. That shouldn't, those two functions should be in the same order, but they're not apparently. So we'll just create this matrix from quaternion, or rather from the conjugate of the quaternion, and let's make sure that we normalize this thing every frame. So now we should have a bit more success. And we do, and it's spinning out of control. Let's slow that down for demo's sake. 5/4. And there we have it. Just a simple demo of loading a model and initializing the matrices in the shader in a basic Cgda application.